Hey, it's Dr. J. Today we're here with 6.3, tax, commission, and discounts. Essentially going to use the principles that we developed in 6.1 and 6.2 involving percent and just apply those to some more realistic situations. I know we talked a little bit about it in the last section, but we're going to get much more into it. One notational note. We're going to have values in this lecture that involve things like price, and in the next section, principal and things that start with the letter P. So to avoid confusion with things like percent and price, that's a terrible. Price, principal, things that start with the letter P, we don't want there to be any confusion. And so in this lecture, we will call percent R to be the percent rate. Okay. Instead of percentage, we're going to say rate, right? And so that is the percent. It is a rate. So R is the percentage rate of whatever it is that we're talking about. If we're talking about tax, it's the tax rate. If we're talking about commission, it's the commission. And I'll get all into what, how those problems work as we go. Discounts, you have a 20% discount or something. We'll again call that R instead of P. All right, just so I hope that's not too confusing. Also, when R is given as a percent, we must first convert it to a decimal. So for example, 5%, if that was R, then I would say, convert it to a decimal, I would say R is 0.05. Okay. Now, it doesn't mean that it's 0.05%. Right? It is 0.05 as a rate or as a ratio. Right? It's 5 out of 100 or 1 out of 20, whichever you prefer. Okay, so having put that out there now, I'll go ahead and do some problems. And then if I want to use the letter P will now mean price or principal or something like that. Okay. There aren't really a lot of new formulas in this section, so I can just go ahead and give you an example of the kind of thing we'll talk about. Let's start with tax. All right, so suppose an item has an original price. Now, I say original price, but I could probably just be lazy and call it the price, right? But I really want to be clear that it's the original price before you've paid for taxes. So the word original meaning prior to the taxes. And the tax rate is 6%. Find the amount of tax and find the selling price. Okay. So selling price as opposed to original price. That's the key here. And so what we're going to do is we're going to say, all right, amount of tax, we're going to call that T for tax. You could also call it X, I guess, but you could call it whatever you want to call it. I'm going to call it T. So tax is the rate, tax rate, times the price, P times R. So now P is the original price. multiplied by the tax rate. All right, so that's R, P, and T. All right, I'm just doing part A for right now. So we have the original price. Oh, I said suppose an item has an original price of $52. I don't know why I didn't write that. I think it was over here in the corner and I just forgot to write it. $52.90. I think I mentioned this before when if you have something that's like 70 cents or 80 cents or 90 cents, anything that ends in a zero, the computer kind of automatically throws away that extra zero. If you saw it on the shelf, it would look like that. Yeah, it'd be a, there'd be a zero here at the end. So the original price is 52.9. Now again, I want to be careful with this decimal and dot and decimal points and multiplication. This dot means multiply, and this dot is decimal. And so again, to avoid any confusion, I'm just going to omit the dot and not even put it there. Just put parentheses around it. All right. And then the tax rate is R. So the tax rate, R, is 0.06. 6%, or 6 out of 100. Okay. And then the parentheses are just there to separate the P and the R. So, this is P, and this is R. All right. When you write it as a formula, you can just say PR, but when I write it using decimals, I should use parentheses. This is why accountants have calculators here. 52.9 times 0.06. And so the amount of tax is $3.17. This is rounded to the nearest cent. Which I'm going to do in all of the problems today. I'm going to round to the nearest cent. I mean, if we're talking about money, which we pretty much are. All of these problems are going to do with money. All right. Notice the 4 is less than 5, so we just throw it away. It's $3.17. Okay. So that's part A, amount of tax, T. Now we're going to do part B, selling price. Now, I'm already using the letter P for original price. So for selling price, I'm going to use the letter S. You could also call it the sale price. Although, I don't want to say that in this example because that sounds like it's on sale. It's for sale. It's not on sale. We'll talk about that later in this lecture. All right. So the selling price is the tax plus the original price. I'm going to actually put it in this order. The original price plus the tax. All right, so selling price is original price plus tax. That's why we say plus tax. Yeah. So the selling price will be the original price, which is $52.90. I actually like to write it like money, so 90 cents. Plus the tax is $3.17. And so the selling price is $56.07. And if you want to double check me, 317 plus $3. I just did that with mental math, so don't trust me. Plus $52.90 is $56.07. Yep. Again, you don't have to enter the dollar sign. Round it if necessary. But since it's already been rounded, I don't have to round it again. It's already rounded. So there you go. Okay, so that's the answer to part B. So we got part A and part B. So there's part B, there's part A. In case my stuff got a little confusing here. All right, there you go. Not too bad, right? I mean, it's example 1, so it's something that you've probably dealt with in your life. You know, everybody buys stuff and everybody pays tax. So at least we pay sales tax. Okay, so let's do some modifications on this theme here. Maybe I'll ask you for something else besides just the selling price. Maybe I'll ask you, suppose the original price was $91 and the selling price is $110.83. What is the tax rate? Okay. So this is where the variables become important because you kind of want to think, what am I solving for, right? Well, you have original price, that's P. You have selling price, that's S. Yeah. And then you have tax rate is R. So I like to put a question mark here. R is the thing that I don't know. That's my unknown value of R. So I kind of know which letter I'm solving for. All right. So you've got your model or your formula. You got selling price is original price plus tax. Yeah. And notice there's no letter R here. Yeah. So you need to rewrite T. Right? What was T from the previous example? It was PR. Yeah. So I've got P plus PR. And if you like, you can put the dot there so that you don't forget that PR is P times R. All right, you don't have to have the dot. In fact, I'm going to omit it. But so the tax is the principal times the rate. That's the tax. Yeah. All right, so let's plug everybody in. The sale price was $100, or the selling price, $110.83. The original price was $91 plus 91R. So you're going to put 91 twice there. Okay. So now what's our goal? Keep in mind your goal. Your goal is to solve for R. Yeah, that's your goal. So I need to get R by itself. I like to do this. I like to write it like this. 91 plus 91R is equal to 110.83. I'm just switching it around so that the $110 is on the right-hand side. It just feels a lot more natural. If you don't want to rewrite it this way, you're not required to. You're going to get the same answer either way, but this is the way that I've been solving equations, ever since we first learned how to solve them. So first you got to subtract the 91. So what's $110.83 minus $91 is $19.83. Okay, so that's your tax. You probably already figured that out a minute ago, right? I hope you did. When you're reading the problem and you read, well, if something costs $91, but they charge me $110, you've all experienced this in life, right? You go, wait a minute, it was only supposed to be $91, but no, it's $110.83. That's because they charged you $19.83 in tax, right? And then finally, the last step, you're going to divide by 91. Again, using the calculator, mainly just to speed things up. $19.83 divided by 91 is 0.21791287. Okay, that's a lot of tax. I've never had to pay this much tax. That's over 20% in tax. Yeah. So the tax rate as a percent. So this is as a decimal. I'm going to rewrite this as a percent by multiplying it by 100. So it's 21.79, so on and so forth, percent. All right, so decimal has to be turned into a percent. Because you don't want to say the tax rate is 0.2179, although it kind of is. That is the tax rate. It's the tax rate as a decimal. This is the tax rate as a percent. And I want you to round to the nearest hundredth. So that would be, the dictator is 1. You would just throw all those away because they're all less than 5, or the 1 is less than 5. So 21.79%. That is very high tax rate. California and New York, we have the highest taxes in the country, and we're not 21.79%. At least not for sales tax. That could be income tax if you're getting taxed on your job or whatever, your paycheck. Okay, so that's ridiculously high. But again, I didn't censor any of these questions. I'm just taking them as they come. So sometimes you get astonishing results. Okay, and then so there's basically 3 different versions of the same type of problem. The first one was kind of the most basic, which is just what's the selling price. The second is a little more complicated. What's the tax rate? And then the third is, again, a little bit more complicated. It's finding the original price if you don't recall what it was. Suppose you bought an item and don't remember the selling price. I could go on a whole rant about why this would be important. There are certain cases where you get reimbursed or you'll get a discount or something. In fact, this happened to me recently, where you're only allowed to apply it to the selling price, right? And then one of the main reasons is the state wants their money, right? They want their tax money. They're not going to apply it, whatever coupon or something that you have. It's only applied to the selling price. So, but suppose you don't remember what the selling price was, right? But the tax rate is 9.5%. That's more like California, or it's not the whole state of California, but most counties have that 9.5%. I think in Palm Springs it's closer to 10. It's like 9.85 or 9.75 or something like that. And the selling price was $245.82. So this is the scenario. You remember what you paid. You know the tax in your county or in your state is 9.5%. but you don't remember what the selling price was. So S is what we're looking for. Oh, sorry. I don't know why I wrote selling price. You don't remember the original price. I almost totally blew that. Somebody would have got extra credit. So correction. You know the selling price, you just don't remember the original price. I talked myself right through that one. You know the tax rate. There's your R. Now you are going to have to rewrite that. And then you know your S. So S is known, R is known, but P is the unknown. All right. So question mark just reminds me that that's what I'm looking for is P. All right, so here's our formula. S equals P plus PR. Remember, PR is just the tax. All right. So you know S. S is 245.82. 245 and 82 cents. All right. You don't know P. Now, this is going to be a little annoying because there's P's in two places, but that's okay. We'll deal with that in a second. So you have R, right? R is 9.5%. Now be very careful. Convert it to a decimal. And you might think, well, wait a minute, it's already a decimal. I mean, convert it to a decimal without the percent symbol. So that is 0.095. That is 9.5% converted to a decimal. Right? You could also do it by just dividing by 100, right? So if you ever forget, go back to the beginning of the chapter and remember the definition of percent. Just divide by 100 and there you go. Boom. And then you don't have to think, oh, shoot, I don't remember. Do I move it to the left? Do I move it to the right? You know, how many places do I move it? What do I do? I'm so confused. Just remember percent means divided by 100. So 9.5% divided by 100. Boom, there you go. 0.095. Now, here's where it gets weird, okay? Whenever you see a variable, now, we're getting very close to the end of the semester, so I'm sort of sending you off to algebra, or your beginning or whatever level algebra you go to next, probably beginning algebra. I've taken you right up to the gate, basically, and I'm waving goodbye as you walk through the gate and go off to algebra. And so you'll probably hear this again next semester, but whenever you see a variable with no coefficient, no number in front of it, there is a 1 in front of every variable. Yeah. So P really means 1P, or 1 times P. Also, when you multiply a constant times a variable, we typically put the constant in front of the variable. So instead of saying P parentheses 0.095, we just say 0.095 P. Yeah? It's the algebraic way to say multiplying. Yeah? So this is a step that I don't think I've ever shown you before, and so this is it. You're going to get this first real glimpse at the future here. When you have variables in two places like this, it has to be the same variable. So these are both P's. You can add them together. Yeah, you can add them together or subtract. You can do either one, add or subtract, by simply combining the coefficients. All right. So we call these the coefficients. Coefficient is a fancy mathematical term that means the number in front of the letter. Yeah. And we don't want to say the number in front of the letter. So we say coefficient. We gave it a single name. Yeah. If you still want to call it the number in front of the letter, you certainly can, but everybody else is going to be calling it the coefficient. So we're just going to add those coefficients. 1 plus 0.095, and then put the p after you added them. Now the cool thing about this process is you're always adding 1, right? So it's just going to put a 1 in front of the decimal. And so oftentimes this step is just done mentally. You just take the 1 and the 0.95, you add them together, and boom, you get right to here. So we often omit that step there. Okay. Notice that you're not actually adding the p's, right? You're not going, p, and then another p gives you, p squared, or 2 p's, or whatever. You're not doing that. Or pp. It's 1p, and then 0.95p. When you combine them together, you have 1.059p, or 1.095p. Yeah, that's what I said. Okay, and so now we want to get p by itself. So we're going to divide both sides by 1.095. This time I did not rewrite the equation. I just wanted to show you that you could still get the right answer. It's going to kind of read backwards, like the variable is on the right and the answer is on the left, but that's fine. So you got $245.82 divided by 1.095. And you get 224.493. 224.493. Round that to the nearest cent, so that'll be $224.49. Okay. Just a side question, how much tax did you pay? Well, $245 was the selling price. Remember, tax is the selling price minus the original price. That's the tax. You just take the sale price, what it actually was sold for, and you subtract the original price. The original price was $224.49. I could probably do that by hand, but I'm not going to. 245.82 minus 224.49, and I paid $21.33 in tax. I did the S minus P over here. The S is on top and P is on the bottom. I just wrote them vertically as opposed to writing them horizontally. Okay, so that's how tax works. Tax varies from state to state. It actually even varies from county to county. It could even vary from city to city. So there's lots of different levels of tax. Maybe we'll do one more. Property tax in California is 3% of the purchase price of the property. If a house By the way, the purchase price of the property is also called the assessed value. Just want to make sure I use the right. Right? The property gets assessed and it has a value, and so that's its assessed value. If a house was assessed at $345,000, what is the amount of property tax? These are by far the easiest of the different possibilities. These are like just the real world. You know, you're looking at something and you're like, well, I got to figure out how much the tax is going to be, right? And you can just take out your phone or whatever you have on you and calculate the tax very easy. So these are the most basic ones. So this is really just kind of a repeat of example 1. I'm just asking for the tax. That's all I want right now. In fact, even easier than example 1. So it's the P times the R. So assessed value, purchase price, P. It's also called the principal. That's another name for it. So that's it. We're basically done. We got a $345,000 house. I recommend omitting the comma. And then you're going to multiply that by 3% as a decimal. And that's it. Remember my philosophy, not every problem has to be a problem, right? That seems a little high, but yeah, 10,350. I will double check that, but it seems about right. 345,000 times 0.03. Yep, that's right. That's your property tax bill. Okay, and then you'll just work on these on your own. You'll have various examples of this. And another thing that we talked about in the last lesson was tips. Yeah. A tip is a type of tax. Now, I could be really, mean or exhausting and make you do tax and tip and parking and everything else, gas and everything. I'm not going to do that. There's no need to make it any more complicated than it already is. I just want to know if the basic idea is out there. So I'm just assuming that now the tip is replacing the tax. Yeah. In fact, in some countries, mainly in Europe, the tip is included in the tax so that you don't have to leave a tip, right? So the tax is the tip, right? Wouldn't that be nice, right? And the waiters and waitresses get paid a lot more because they're not expecting you to tip them every single time that you go to a restaurant, right? So a tax and a tip are essentially the same thing, but in the United States, we're one of the few countries that we separate those instead of packaging them all together. All right. I think it would be kind of interesting to look at how much the tax would go away, how much the tax would be affected if we got rid of tips. Yeah. But that's more of a economics and philosophy question, a human behavior type thing than it is a math question. So I'm just asking a straight up math question. All right. So how much is the total? Again, you can use the same formula. The bill is P. That's the original price. Yeah. The tip is the same as tax, so that's going to be your R. Yeah. So you got P plus PR. So originally $78 plus $78 times 15%. Remember, the same as tax. 15% is 0.15. So $78 times 0.15 is $11.70 plus 78 bucks. $89. I didn't even need the calculator. I feel silly that I even used it for that one. That's $89.70. I like to make it look like money, so I put 70 cents like that. If you leave off the last zero, it'll still be correct, but just looks funny. Looks like there's a missing digit or something like that. All right, that's enough with tax. Let's look at the bright side of this formula. Discounts. I know in my title, discounts were listed last, but I'm listing them second. So discounts. It's sort of the reverse of tax, right? A discount is taking off a certain percentage from the price. So if you have a discount, you have to have what's called a discount rate. All right. Now I want to be careful. There are two important words, off versus of. Really have to be careful with these words, off versus of. And it might sound like, really? I have to be careful? Well, I know the difference between off and of, but look at how similar they are. Off, O-F-F, of, O-F. And they mean completely different things, yeah? So if I say R is 20%, and I say 20% off, yeah, then that means you are subtracting from the original price 20%, which is 0.2, times the original price. I don't know why the arrow is going there. The arrow should go here. 20% becomes 0.2, yeah, or 2/10, 20%, yeah, or 20 hundredths. Yeah. Now it's off because you are subtracting 20%. So that would be the sale price. So the sale price, I don't know if you can see that. The sale price is S, which is the original price minus, because I'm taking off, 20%. Now let's compare that with of. Yeah. If I say R is 20%, and I say, what is 20% of P, not off, but 20% of P, that is just 0.2 times P. Which is just this piece here. So what am I getting at? Well, look. Remember what I did before with that invisible 1? There's an invisible 1 right here in front of the P. And I like to move my coefficient to the front of the P like that. What's 1 minus 0.2? 0.8. Yeah. 1 minus 0.2 is 0.8. So that is the difference between of and off So in general, if you like to just memorize this, R percent off is the same as 1 minus R percent of. Yeah, see? 20, 80. Yeah. So you could make a little chart. If you say 20% off, you mean 80% of. If you say, 15% off, well, that means 85% of, etc., etc. If you say 40% off, that means 60% of. Yeah. So it gives you a way of immediately, as soon as you read it, you got to go, well, is this an off or is this an of? Yeah, because off and of always differ by 1. Another way to think about it is they always add to 100, because that's what 1 really means, right? 1 really means 100%, the full price. Okay, so I've already given you the fair warning ahead of time, so now let's do some problems, and then as we're doing them, we'll decide which version we're going to use. Six, am I up to 6? Yeah. So, suppose you paid $140 for an item that was originally priced at $500. All right. What percent of, kind of gave it away there, the original price did you pay? All right, so you paid $140. That's your S. That's your selling price or your sale price. The original price was P. So your formula is the sale price is P minus PR. Okay. Okay, and so this would be off, not of, but off. We want of, what percent of? So that's going to be 1 minus R times P. Remember, there's the invisible 1 here. 1 minus R times P. All right, and now let's plug everybody in. S is 140. 1 minus R times P. P was 500. Let's see, how do we want to do this? There's a couple different ways to solve this. I'm just thinking before I jump in. I think I'm going to do it the easiest way possible now, and that would be to just divide both sides by 500. Let's divide both sides by 500. There's a more complicated set of steps, but let's do the easiest one is to get rid of that 500 first and get it to here. So now you have S divided by P here. S divided by P equals 1 minus R. And this is what you want. You want what percent of. So you want 1 minus R. You don't want R. You want 1 minus R. So therefore, 1 minus R is equal to 140 over 500. 140 divided by 500 is 0.28. So this is the percent of the original. So that's 28%. Don't solve for R yet. We don't want R. We want of. All right. So note, if we were asked, which I will probably ask, I'm just giving you kind of a fair warning here. If we were asked what percent off, then you would solve for R. In other words, get R all by itself. You can do this with mental math, by the way. From what I just talked about, if the percent of is 28, then that means the percent off is 72. All right? Remember, 1 means 100. Yeah, 100%. So 100% minus 72% would equal 28%. I always recommend doing that mentally. If you want to actually do all the steps, that's kind of what I was saying earlier. There's a more complicated set of steps where you move the 1 to the other side and you divide. And there's no reason to do all that unless you really want to suffer. You will still get 72, but it's just so much easier to just go, okay, that's 100. That's 28. So 100 minus 28 is 72. So I just do it mental math. R is always 100% minus the of. The of value. Yeah. So 100% minus 28% automatically gives you R. All right, I hope that wasn't too confusing. I mean, if you ask 5 people how to do these problems, you're going to get 5 different answers. I have a hidden objective here, and that's not just to have you find the easiest way to get the right answer. That's not my main objective. That's a side objective. My main objective is to teach you the algebraic thinking process so that you're much more prepared for algebra. You know, I almost feel like I'm sending you off to school, you know, because I'm not going to be there to guide you through this. So it's going to be somebody else explaining this to you. So anything that I can do to sort of ease that bridge, I want to do it now. So I caution you because we're almost done. You could easily look up a very, very quick, easy fix for these problems, but then you're not going to be learning the steps that are going to be very important in the next class. And I know I sound like I'm like, you know, be careful, you know, follow the rules, you know, but okay, and there's enough of that. Okay, so let's go on and do another one. Example 7. Suppose you paid $70 for an item that was 45% off. What was the original price? What was the original price? 45% off. So what was the original price? Honey, can you get the door? So you paid $70. That's your S. That's your sale price. 45% off. Yeah. So that means R is 45% or 0.45. 45%. Rowan, can you go out there and just tell them I'll be right there? I'm busy. Give me 5 minutes.
Give them 5 minutes.
They keep knocking, and I need you to tell them I'll be out there in 5 minutes. Maybe 10.
Sure?
I'm almost done. They've knocked twice. I don't want them to knock again. So S is P minus PR. 1 minus R times P. Yeah. R is 45%. Percent off. So I'm going to subtract that. I actually know S, so why don't I just put it in there? 70. And then 1 minus R, that's 1 minus 45%. You could do that with mental math. That's 55%. The gardeners keep knocking. I asked Rowan to go out there. It wasn't the garden, it was mail. Oh. So we're trying to solve for P. Sorry, we keep getting interrupted with knocks and things like that. So we got 55%. Right. Again, I might want to make a note, mental note, 45% off means 55% of, right? So 55% of, you've gotten rid of the 1 minus part. And now you're going to divide both sides by 55, 0.55. And do it on your calculator. So $70 divided by 0.55 is P. I'm coming over here now. P is 70 divided by 0.55, which is 127 and 27 cents. Now that's an interesting decimal. It's 27272727. That's a repeating decimal. It's a coincidence. It's kind of somewhat related to previous topics, you know. So when you divide by 55, you end up with 27272727. Does that sound familiar? Yeah. I'm rounding, so I'm just doing $127.27. There you go. So that was the original price of the item. All right. What other kind of discount? I'm trying to show you one of each type, at least one of each type of discount problems and tax problems and so on. I might have to cut this short and go to a part 2, but let's see how many more I can get done before my hour is up. I've been trying to keep these down to an hour without any distractions or interruptions, but I have a feeling I'm going to get interrupted again. So, example 8. I think I'm up to 8. Or was that 8? I keep getting interrupted and distracted. I don't even know what I'm doing anymore. Let's see. don't know why I did the hard problems first. I should have done the easy ones first. Suppose an item has an original price of $98.75, but it is on sale at a discount rate $17 off. Okay. So, by the way, a discount rate, if that red pen is done. If somebody says a discount rate, that automatically means that automatically means off. Yeah. So sometimes we won't even say off. We'll just say a discount rate, 17%. Discount, 70%. And then that is implied to mean 17% off. All right. That's to avoid that off controversy or ambiguity between the two different versions of that. So you know what I'm going to ask. I regrettably wish I just would have done this one earlier, but that's okay. I mean, you don't always have to get the problems in the exact simple to hard order. So I did the harder ones, and now I'm doing the more simple ones. What is the selling price or the sale price? So S is the original price minus the discount. So the discount is 1 minus R times P. Remember that invisible 1 there. Your R is 17%, and your original price is $98.75. You can do this with mental math, right? 1 minus 17% is 83%. Times 98.75. I'm just putting parentheses to indicate that I'm multiplying. All right, so mental math from 1 minus 0.17 all the way to 83. If you have to use the calculator, that's fine. And so you're going to get 83%, right? And then 98.75 is $81.96. So that's the sale price. Okay, it's coming up on an hour, and I got to get to the office hours. So I'm going to stop now. In my next video, part 2, I'm going to talk about markups, which actually weren't listed in the title, but if you can have something go down in price, you can obviously have something go up in price as well. So you can have a markup. And then I also want to talk about commission. So I'll say goodbye for now until we meet again. This is Dr. Jordan. I'll see you on the internet.